Makerspace can be small, they can be Legos, and they can be large too. This is a large project that I did with some folks last fall. This is a hovercraft, and it's a hovercraft that can carry 2 people on it. It can do about 20 miles an hour over land and water, carrying those 2 people. And I wanted to introduce some of the people that actually made this hovercraft. There they are. So that's Kobe, age 7. That's Lily, age 5. Ermi, who's 11. Quinia, who's I think 8. And in the back, that's Calliope, who's 8 as well. So here's what I saw that they learned. The first was this shaping their world. So they now know that when they try, they can build something that's pretty substantial, that they have the capacity to shape the world around them. The second thing is the confidence that they can go ahead and do it. So I think when they're faced with what I call open-ended, evolving, complex problems, they're going to know that they can actually pull it off. Those sorts of problems have another word, it's called real-world problems. So they've got some practice at it. So here's an example. That seat that they were sitting on is something that they designed from scratch. So they went out and figured out what the design constraints were on top of the hovercraft, what they needed to do, and then they proposed a couple of prototypes, settled on one, built it, and now it's sitting on the hovercraft. So there's a group at Harvard called Project Zero, and a subgroup under them that is called Agency by Design, and they're studying what kids get out of makerspaces and maker-centered learning. And I think the biggest part is this last part, in that it empowers them to engage with and shape the design dimension of the world. And again, it enables them to shape the world around them. So that's the why for makerspaces. I thought we should talk a little bit about how, and I want to start off with how not to. What most people do is they buy a 3D printer, and then they say, well, how can we figure out how to integrate this? This is what my usual conversations with school goes. They call up and they say, hi, we want to build a makerspace, to which I say, why? And they say, because it's what everybody else is doing, right? And we need to do it. We are a leader, we're progressive, and we're at the forefront of educational technology trends, whatever that means. And we need a makerspace. And by the way, which 3D printer should we buy? Okay? So it really is, if you build it, they won't come, and you shouldn't start with your 3D printer. And here's why. Working into a makerspace, working it into your curriculum, really requires a big shift in mindset for most teachers. And this ability to think about shaping the world around you, it's hard to teach if you don't really believe it yourself. Okay, so it's a huge mindset shift for teachers and for schools. It's also very experimental, and my observation in most schools is that the culture really doesn't support that sort of experimentation. So I wanted to talk about how we shift mindsets for teachers. Last fall, I did a program with Oakland Unified School District that we called a Maker Fellow program. And the Maker Fellow program was designed to answer 4 questions. One was, how do we shift the mindset for teachers? Why is this a particularly exciting time to be a maker, and what technologies make it so? What does this look like in the classroom from K through 12? And last of all, what is the relevance of these types of skills? So the first project that we did that goes back to how do you start to shift mindsets for teachers, they did the morning of what we call a thinking routine called Parts, Purposes, and Complexity on the table. So parts, purposes, and complexity is you have to take apart a table, examine every single part, look at how it's complex and how it fits into the whole. And the point of this is to teach some real observation skills about the world around us. I could see the look on the teachers' faces when they started, that they were going to be done in about 5 minutes. They're like, why don't you give us something difficult next time? I came back about an hour later. There were tables and pieces all over the room. They had huge diagrams, and they were still going strong. That afternoon, I had them take what they'd learned about the tables and design one and build it. So they had to build a table out of 2x4s, 4x4s, and plywood. So this is Linda Rogers. She's been in the classroom for about 30 years. She was just nominated as the Teacher of the Year in Oakland. And this is another team. They're sitting on the table that they actually built. So take this. You don't have to do this particular exercise, but it's really, really important to figure out how to shift that mindset. The practice of teaching in a makerspace or integrating it in is very, very different from what most people are used to. It can be very intimidating, moving from a total stand and deliver to a coach and get out of the way. So I wanted to conclude with, that's how not to do it, is to buy the 3D printer and hope that you can figure out what to do with it. Here's a process that I actually take schools through when I work with them. But it starts with, what are your hopes and dreams for the space? By the time you're talking about it, you've got stories. You have hopes and dreams for it. Get those on paper. Post-its are a great way to do that. But get them all written down. The next is define what the skills, knowledge, and habits you want. You first have to start with what is a skill, what is a knowledge, and what is a habit. And I frequently see schools that have never done this for their graduates as a whole. So figure this out for the space. I mean, it can be as simple as measurement. We want kids to be able to measure, to creative problem solving, but you can define it very carefully. Then figure out what the culture is in the space. And by culture, for example, one big component of culture in the space is safety. So how do you balance creative experimentation with tools with wanting to, quite legitimately, to avoid injuries in the space? So you can start to figure out what that culture looks like. What are the rituals that support the culture? Then figure out the curriculum integration points. So curriculum integration points can be places that you find of interest. They can be the most exciting teacher. They do not have to be math and science. Lots and lots can be done with English and history, social studies. One school that I'm working with in California, in 4th grade, they had to study the areas of California, the geographic areas. So they built a scale model, complete with lights that light up and things that call interest. So there's ways to do this and tie it into the softer subjects. Once you figure out those points, then figure out your curriculum, then figure out your projects. You can define the projects, how they're going to be introduced, how they're going to be assessed, and what they are. And then, and only then, do you figure out the tools, the materials, and the space design. And that is just the opposite from what most people do. You do not need a $250,000 makerspace to get started. You really don't. You don't even need a 3D printer, okay? So that's what I wanted to go through. And I think now that's the why and some of the how.